Hey everyone. This is an extension of the previous video in which we were looking at how we get into doing descriptive statistics in R. And this will be sort of like an addition to that. We're going to go on and we're going to be looking at a couple of different things. First of all will be how we do some of the visualization of these descriptives. And also how do we interpret some of the error messages that we might see when we're in R. So let's get down to our R screen here, down like so. And here you'll see I'm basically back where we left off last time. If you weren't following on with the last one, you can see a few of the commands in here that we were using to find our descriptive statistics from our heights_long data, and really using this describe by function that will give us all of the data that we really need in terms of descriptives. And there's other ways to get it that I showed in the video, but this is kind of a fast and easy way to just find some descriptives for our data. So if we want to move on and start thinking about maybe visualizing some of these descriptive statistics, like I showed you before in the last sort of part of the video, we could always just use plot, which is built into R. So the plot function will basically ask, what do you want to plot? Here we can give it two things, X and Y. We can see the little tip strip that it gives us, tells us it needs an X and Y. But realistically, if I just tell it that I want it to plot for me heights_long, and I'm going to hit Control Enter. In the screen behind me, in fact, because this is visualizations, I'll throw myself up into the top corner so I'm kind of not in the way the whole time. So when we use this function, I'm just going to hit Control Enter to run that line. What we see is we do get some kind of visualization. All it's doing is plotting the individual data points, and it's using sort of like a numeric value for sex, 1 being female and 2 being male, and you can see all the different points. So that gives us some kind of visualization of maybe the range and where we might see if there's any skew in the data or not. Another way we can use some visualization might be using the function which is boxplot. And essentially we do it slightly differently, but it actually looks much more like this describe by function here. So I'm going to actually steal that by using Control-C copy, Control-V, or Command-V for you Mac users. And instead of describe by, we're going to use the function boxplot. And our inputs are going to be height as a function of sex and data equals heights_long. And we'll see what that gives us. So if I run that command, now we see we get box plots. And in fact, I'm going to click on this button, zoom, and it's going to pop it out for us here so we can have a better look at what's going on here. So effectively, this is giving us what we call box plots. And box plots give us the median, which is the big thick line, the lower and upper quartiles, which are represented by the box. And then these whiskers here with the lines represent, in this case, they represent the extent of the data. So the highest and the lowest data points that there are. If there are outliers, so outliers would be anything beyond 1.5 times the interquartile range. So if we had some value that was more than 1.5 times that, say it's down here somewhere, there would be illustrated by a little dot on your screen. So this will just give us the extent of the data, or 1.5 times the interquartile range plus any outliers that are outside there. So this gives us a really good idea, depending on sex, males and females, what the descriptive values or what our data really looks like. So we can automatically see that, hey, look, that for females, our heights range from about 150 to 180, with the bulk of them in this just 159 to 170 range. And for males, it ranges from maybe 170 to just over 190. And most of them are in sort of the 175 to 185 sort of range. So it gives us a really quick way to visualize our descriptive statistics for this data set that we've got right there. Another way that we may want to look at our data is by using a histogram. What a histogram will do is give us our frequencies or our counts of any height bin. So why don't I give you an example of that right now? So if I just type hist, so that's going to be our function that we're going to call for a histogram plot. And let's start off by just going heights, F, $ height. So remember we had made this data frame, heights F, which essentially is just height by sex, but for only females, right? So what that will do, if we run that command, hist of heights F height, we can see that we get a histogram. Now we see that, oh, there's 3 people that are between 150 and 155 centimeters, 4 people between 155 and 160, and then so on. 5 people, 160 to 165, etc. I could do the same thing if I copy and paste that function and just go height M height. And I get the histogram for the heights of the males. And then we could see our counts of the different heights for our male set. Now, if I wanted to look at the entire data set, not broken up by sex, I could just go hist heights underscore long $ height. So that's where it's got both males and females. And we can see that that's got now the entire range. We've got different counts. But remember, these include both males and females. So I guess our question would be, if we want to make some histograms that are broken up by sex, how can we do that? What I'm going to do is show you a couple of different ways we can do that by using 2 new packages. Now, one of them is going to be a package that's actually not one that you can download using this packages, because there are some packages that are not included in sort of the repository where you can click on this install button. So you have to use a different set of commands. In order to use those other sets, they come from GitHub. You're going to have to, first of all, install a package called DevTools. So we're going to install DevTools. DevTools like that. I'm going to hit enter. And we can see that it's going to run, download them. Yours might take a little bit longer, but once it does that, it should be good to go. Okay. Now, once we've got that, we're going to need to run a couple of commands here. So the first one is going to be DevTools. So you're calling DevTools. I need 2 colons here to say, I want to use a function that is under DevTools. Now, you don't need to worry too much about this. We're just going to need to use this to install one specific package that we're going to be using today. So we're going to use DevTools, install underscore GitHub. So that's this one here, not GitLab, GitHub. Okay. So install GitHub. We're going to put in quotes, Dustin Fife. That is the writer of this package. And we're going to go / flexplot. Okay. So install GitHub, Dustin Fife, so Dustin F-I-F-E / flexplot. Now we'll run that. I use Control Enter here, and you're going to see that it's going to now start running a few different things. basically says, for me, it might say, these packages have more recent versions available, so recommended for you to update all of them. I'm not going to do that right now. I don't need to enter one or more numbers or empty line to skip updates. I'm just going to skip updates. So it should now run this command, install everything, and it should be happy when it's done and give me a confirmation at the end that it actually worked. We'll find out. It's doing it, building, testing if installed, testing it can be loaded. Done, flexplot. Good times. Okay, so we now have flexplot. And again, once that's installed, we do need to load it by using the library function, library flexplot. I run that, so now flexplot is loaded. We're good to go. Okay, so flexplot is a great tool for visualizing your data. And there's a couple of really nice functions that it does. And basically the syntax for flexplot is flexplot, and it's going to be something like y-axis as a function of x-axis plus colors. And we use this bar for column panels and plus row panels. And you'll see later on why it's structured this way. But for the most part, you actually don't need to worry about all of this. This just gives us a lot of flexibility to do what we want. So we can say, what's on my Y? What's on my X? Do we have multiple things? I can separate them by different colors. And now do I have a bunch of different maybe categories that I want to put in panels and different row panels. So I can make basically a matrix of graphs with this if I want to. But we're not going to look at any of that basically. We're not going to run that command. I just wanted to show you essentially what the syntax of flexplot looks like, or what the grammar of flexplot looks like. So we're going to basically look at the first one being, we go flexplot height. And remember, this sort of structure is now going to be quite common and something that we're going to be seeing fairly often through a bunch of different packages. So it's going to be, in this case, it's going to be y as a function of x, and what is your data? That's what we're asking for, right? We want height on the y-axis, sex on the x-axis, and that's what we saw before, right? For the box plot, we saw height on the y-axis, sex on the x-axis, and telling it what data we need. We're going to copy that same thing, and we're going to put that in here. Height as a function of sex, and data equals heights underscore long. We'll just see what that gives us. And we can see that gives us actually quite a nice plot that gives us what looks very similar to boxplot. And we'll talk about what this is a little bit more later. But this is a really nice way to get descriptive plots very quickly. Another thing we might want to do is let's just copy that. And we might want to say, I want height, but I want a histogram of height. And when we do that, we want to say, I want height as a function of basically nothing. So on the x-axis, I just want one thing. So when we say height as a function of 1, that basically just means that we want height as a function of a histogram. So give me the counts. When I run that, you'll see we get a histogram that looks very similar to what we did when we saw when we made our histogram of all of the data here. If I run that one again, you'll see it looks slightly different, but it's just the bin sizes are slightly different on these. So we can do that. Or we could go height as a function of 1, and the data is now actually heights f. Now we get female height data, or height as a function of 1, heights for males, the male data. Or, I'm going to copy paste that again. Why don't we say, hey, we want a histogram of sex as a function of 1, data equals heights long. Now what does that give us? Interestingly, this is giving us a histogram or a bar chart of basically the count variable of females and males. We've got 20 females and we've got 16 males. So all this is doing is with the number 1 is it gives us a histogram of the counts of various things. When it's categories, it's really easy for it to count them up. When it is a numeric variable, it'll put it into discrete bins that you can basically tell it what size bins you want, but you don't have to worry about it. It'll do it automatically. Now, remember I said we want to look at maybe a histogram, but it has both on the same graph. Well, remember this grammar here, I can give a couple of different panels. So why don't I try that? I go flexplot. I'm going to go, it's height. Let's get rid of that. Height as a function of 1, paneled on sex, and data equals heights long. Now I see them both at the same time, right? Now what's really nice about that is it actually gives us down here sort of the entire range of both data sets. And so we can see that, for females, they're actually in the lower half of this data set. We can see a histogram of what those look like. And for males, we can see that they're in the upper half, right? So the range goes from 150 to almost 2 meters here, and 150 to 2 meters for both, but we can really make this easy comparison between both of them. So flexplot is one that we're going to be using quite a bit as we go on. So keep your eye out for that. And again, the syntax for it is fairly easy, and we will learn this as we go a little bit further along. So let's do a couple more examples of what we can, how we can visualize this data. So the first one might be using, the first one is using another package called sjPlot. So let's install that package. So we'll just use the command this time. Packages, and in quotes, it's sjPlot. And so it's saying that's, nope, it's saying that I've actually typed it wrong. It's actually sjPlot. So I actually gave it the wrong command there. So let's try that. So it's sj, small s, small j, capital P plot, right? And there we go. So it's successfully unpacked and installed, so we should be good. So now we're going to library, sjPlot. That means we've loaded it. And now why don't we actually run that command? And funny enough, it's going to be basically the same syntax as flexplot. So flexplot, so now it's going to be, it's not flexplot, but it's going to be sjPlot. So it's sjPlot. And notice that the command is actually all small letter or all lowercase letters, sjPlot, height as a function of sex, data equals heights underscore long. And now you can see that it gives us something that looks like, the histogram for both, but it's given us numbers in here. It's a little bit messy, but we'll see that sjPlot's actually very useful in other ways later on. I'm just giving you an example of different graphics packages that we can use and that we will use, and how we actually use those, and wanted to give you a sense that the syntax for them is all very similar. What's on the x-axis, what's on the y-axis, what's on the x-axis, and then what's the data. The last one I'm going to talk about here is sjPlot. So that's actually included in the tidyverse package that we installed previously. Now, if you didn't install that, we can install the tidyverse, which is install.packages, tidyverse, and you're going to run that. Or if you actually just wanted sjPlot, it's sjPlot2. And we can run that. It's telling me that some packages are currently loaded. Do you want to reinstall or restart that? I'm just going to say no. It's telling me sjPlot2 is in use because I actually just already loaded it. But we will call it again, library sjPlot2. There's, just to note, there's a 2 in there. Library sjPlot2. And that loads that library. Okay. Now, there's an entire chapter in the data science for R second edition that is devoted to showing you how sjPlot works. So sjPlot is a very it's a very flexible graphing, plotting package, and it runs on a particular set of grammar where you sort of build up layers on a graph, and you have to tell it what the data is, and then what the axes are, and then what the things you want on it. Is it a line? Is it dots? Is it all whatever? There's a whole chapter on that in the R for Data Science second edition, so I'd suggest you go through that if you're looking for a really good intro to sjPlot. I'll just show you an example of how this will actually work with our data here. So the way we would use sjPlot will be, you would call the function sjPlot, and we're going to tell it the data first. So heights underscore long. And then we give it what's called an aesthetic. So we have to tell it what the aesthetics of the graph are. So the aesthetics are that x equals height. Okay, so clearly we're going to want to then say, oh, is there y? Well, we're not going to worry about this. There is no y if we want to do a histogram. So then we say, great, x equals height. And then we're going to add a second thing, a geom. So basically it's a geometric object to that. And it's a histogram. So basically we could say we want a geometric object of a histogram, and we have to give it aesthetics too. Say AES. And then color is sex. So basically we're telling it on the x-axis, we want height. So that's going to be our various heights. And then we want to have sex displayed in different colors. And all we want to do is see a histogram of that. And then the last thing I'm going to do, I think I've got too many. Oh, no, that's all good. After that, we'll just scroll over so you can see. Actually, what I'm going to do, I'm going to put this geom on a second line. So we can actually just add this into a second line and it doesn't care. So I'm going to just put it after the plus. Geom, histogram, AES, color equals sex, comma, alpha equals 0.2. So alpha basically means its transparency level. All right. Plus, I typed that wrong. So we want to make sure that that says plus geom underscore histogram, open bracket AES, open bracket color, and then this close bracket goes with the first close bracket, and this close bracket goes with that second close bracket. We want to make sure we have all the brackets open and closed. So when I run this, which is, even though it's split over 2 lines, it thinks of it as 1 line. I go Control Enter. You can see that creates a nice histogram graph here where we've got both sexes plotted. Now, again, like I said, we're going to have, there's a chapter in the Data Science for R book that you can go through, and it'll give you a really good tutorial on how to use ggplot. And in fact, when I was showing you flexplot here, it's basically calling ggplot in the background and applying a bunch of functions to it. But this just makes it easy to use ggplot or in an easy way. Flexplot allows us to look at graphs really quickly how we want to. ggplot is very flexible in how you can create any type of graph you want, but it is a lot more complicated to build up the layers that you need to create that plot. Just wanted to show you that you can do that. All right, so lastly, what we'll do is we'll talk about some of the errors you might encounter. You might have seen some of them that I've actually run into already. So one thing you want to do if you find that you get an error or something doesn't happen as expected, check spelling or typing or missing brackets or whatever. So that's really the first thing, because this is a text-based command structure. You might actually just make a few mistakes on your spelling. I'm going to drop myself back down into the lower right here because I'm not showing the graphs anymore. So you might have some problems with your spelling, and that's really the first thing that I check, because I always make typing mistakes. So that might be something else that you want to do as well. So we might get errors that say, for example, say we did mean of heights underscore long, but instead of height, we ask for the mean of sex. Now, we get a warning message or an error in the bottom that basically says, well, the mean is NA, and it says the argument is not numeric or logical, therefore it's returning NA. And what this is just basically saying is that you can't take a mean of a categorical variable like sex. There is no mean of sex. There's no mean of categories. So that doesn't make sense, and so just check the variable that you're trying to look at instead. So instead of that, you don't want to use, you don't want to get a mean of sex, you want a mean of height, and then we actually get a value that is returned that is correct. Or you might want to, try and get a mean of height, but maybe you actually spell this a little bit wrong. Height lung. It will say error object heights lung not found, which basically says that that object doesn't exist. You might have spelled that wrong, or it might be heights skinny, or it might be something that just plain doesn't exist at all. So that might be an issue. You just want to make sure that you do have the correct objects and you're referencing the correct things, because this object height skinny doesn't actually exist. And if you tried something else different, like a column that doesn't exist, mean heights long, just said weight, it's going to give you another error saying the argument is not numeric or logical, it's NA. There's no thing called weight as well. So some errors might come up if those things just don't exist. So one thing when I was doing this ggplot figure, there might be some issue. Remember I told you that there needs to be open and close brackets for each of the different parts of this. And it's really easy to screw up and not put in the right bracket. So if I put one there, an extra one at the end and ran it, it says error unexpected bracket in ggplot this. So it really tells us exactly what the error is. And then I can search for where that is, say, oh, right, that's right. It shouldn't be that. It should be that. That will give me the correct thing to create the figure that's behind me there. So that's another error that you might run across. You might get another error if, for example, maybe you don't have a certain file. So for example, I wanted to load a file, and we'll take this right from the very top. Remember, the very beginning we had heights. In fact, doesn't matter. Let's do this. Copy this. I'm going to paste it there. Say we said into heights long, we decided we wanted to write data heights, but we put in heights long.csv, which doesn't exist. We try and run that. It's going to say error cannot open the connection. So it cannot open file, no such file or directory. So oftentimes, like I said, read what the error message says and try to decipher what it's telling us. It's telling us, hey, look, no, that file doesn't exist. So you want to make sure that that file is there. So just make sure that those exist. Those are some of the most common errors that you're going to come across. So hopefully I've given you some idea about how to visualize some of your descriptive statistics in R and how to decipher some of the errors that you might come across in R. All right, until next time.